Good afternoon, everyone. This is Mary Grace Besa and we are the Group 4. The topic that we will be discussing is Chapter 4, An Introduction to Management Science. So, Chapter 4 is all about linear programming applications in marketing, finance, and operations. The learning objectives of this chapter are, first, to be able to understand on how marketing managers allocate their fixed budget to various advertising media. Second, to be able to understand financial decision-making that involves capital budgeting, make or buy, asset allocation, portfolio selection, and financial planning. Third, to be able to understand how operations management in aiding the decision-making about product mix, production scheduling, staffing, inventory control, capacity planning, and other issues. And lastly, develop mathematical models for each application. So the reporters are Ms. Mary Grace Besa in Marketing Applications, Mr. Kyle Jairi Padernal in Financial Applications, and Ms. Jeneline Layson in Operations Management Applications. So first, we will tackle marketing applications. So linear programming is a useful tool when it comes to marketing applications, for it generates solutions that are based on the characteristics and feature of the actual situation or problem. Therefore, the application of linear programming is very broad and can find solutions in diverse fields like marketing. So one application of linear programming in marketing is media selection. Media selection means the process of choosing the most effective media for advertising to achieve the required coverage and number of exposures in a target audience. So, for example, a marketing manager can use linear programming to allocate a fixed advertising budget across several media channels to maximize audience exposure. So, the objective of media selection is to maximize reach, frequency, and quality of exposure. Restrictions on the allowable allocation usually arise during consideration of company policy, contract requirements, and media availability. So from media selection to market research, linear programming has many benefits as a tried and tested problem-solving method that can enhance the decision-making process. This technique is especially useful when there are constraints or restrictions when it comes to making a decision in certain application of marketing. Now let's see this example of media selection. So, S&M Company recently developed a new instant salad machine, has $282,000 to spend on advertising. The product is to be initially test marketed in the Dallas area. The money is to be spent on a TV advertising blitz during one weekend, so Friday, Saturday, and Sunday in November. The three options available are daytime advertising, evening news advertising, and Sunday game time advertising. A mixture of 1-minute TV spots is desired. So SMM wants to take out at least one ad of each type, so the daytime, evening news, and game time. Further, there are only 2 game time ad spots available. There are 10 daytime spots and 6 evening news spots available daily. SMM wants to have at least 5 ads per day but spend no more than $50,000 on Friday and no more than $75,000 on Saturday. So, in solving this problem, we must first identify those decision variables. So in this problem, we have 7 variables. So let's define each one of them. We have here DFR as the number of daytime ads on Friday, DSA as the number of daytime ads on Saturday, DSU as the number of daytime ads on Sunday, EFR as the number of evening ads on Friday, ESA as the number of evening ads on Saturday, ESU as the number of evening ads on Sunday, and GSU as the number of game time ads on Sunday. Next is we will identify the goal of our problem. So we will identify our objective function. So objective function specifies a direction of optimization either to maximize or minimize. So para makakome up ta sa tong objective function, we will base on our given. So based sa given sa atong problem, nakabutang man diri ang dapat ma-reach sa daytime, evening, and Sunday game. So if ma-identify na nato, we can already define our objective function. So our objective function is to maximize the total audience reach. So we have here to maximize 3,000 DFR plus 3,000 DSA plus 3,000 DSU plus 4,000 EFR plus 4,000 ESA plus 4,000 ESU plus 75,000 GSU. So this ang manigikan nitong amount. So diri nigikan sa reach with each add sa given nato kay atong objective function man is to maximize the total audience reach. So mao ni siya 3,000, 4,000 and 75,000. Next is we will define our constraints. So atong mga constraints serves as mga limitation ni nato sa atong objective function. So magsugod ta sa each type which are the daytime, evening, and Sunday game. Nya sa daytime kay nag-include ang Friday, Saturday, and Sunday. So it means ang atong buhaton is i-add ni nato tanan sa daytime and we should get greater or equal to 1. Kay it is said nga at least man, so it could be 1 or greater than it. The same sad sa evening time and Sunday game. So we have here sa daytime, DFR plus DSA plus DSU is greater than or equal to 1. So morning sa daytime, adds on Friday, daytime adds on Saturday, and daytime adds on Sunday. Then sa evening time, EFR plus ESA plus ESU is greater than or equal to 1. So evening add on Friday, Saturday, and Sunday. And sa Sunday game, which is GSU, is greater than or equal to 1. And another constraint is 10 daytime spots available. So nakabutang man diri nga there are 10 daytime spots and 6 evening news spots available daily. So i-include sad ni nato. So sa 10 daytime spots, nag-focus man sa daytime, so it should be daytime and tagsaon nato sa Friday, Saturday, and Sunday. Maong we have here daytime ads on Friday is less than or equal to 10, daytime ads on Saturday is less than or equal to 10, and daytime ads on Sunday is less than or equal to 10. The same sad sa 6 evening news spots available daily. So we have here evening ads on Friday is less than or equal to 6, evening ads on Saturday is less than or equal to 6, and evening ads on Sunday is less than or equal to 6. So why less than or equal atong gigamit? It's because ang naka-indicate ra adto is there are 10 daytime spots and 6 evening news spots available daily. So wala man nagingon og at least or unsa nya. Maximum naman na siya, so dapat less than or equal ra siya sa 10 and 6. And then other constraints sad nga gi-state sa problem is only 2 Sunday game time ad spots available. So nakabutang sa dire nga there are only 2 game time ad spots available. So i-include sad ni nato. So GSU as game time ads on Sunday is less than or equal to 2. And then next is nakabutang sa diri nga SMM wants to have at least 5 ads per day. So at least 5 ads sa Friday, Saturday, and Sunday. So DFR as daytime ads on Friday plus EFR as daytime ads on Friday is greater than or equal to 5. So greater than or equal tungod kay at least 5 ads man. And then DSA as daytime ads on Saturday plus ESA as evening ads on Saturday is greater than or equal to 5. The same sa Sunday. So DSU as daytime ads on Sunday, ESU as evening ads on Sunday, plus GSU as game time ads on Sunday is greater than or equal to 5. And then balik na sadta nakabutang diri nga at least 5 ads per day but spend no more than $50,000 on Friday and no more than $75,000 on Saturday. So gamito nato diri ang estimated cost per ad which is 5,000 sa daytime and 7,000 sa evening. Nya we have here spend no more than $50,000 on Friday. So 5,000 DFR plus 7,000 EFR is less than or equal to 50,000. So less than or equal to 50,000 kay spend no more than man, so dapat dili na mo labaw pa sa 50,000. And as well as sa Saturday, spend no more than $75,000. So 5,000 daytime ads on Saturday plus 7,000 evening ads on Saturday is less than or equal to 75,000. And next is spend no more than $282,000 in total. Kay nakabutang man sa didto nga has $282,000 to spend on advertising. So 5,000 DFR plus 5,000 DSA plus 5,000 DSU plus 7,000 EFR plus 7,000 ESA plus 7,000 ESU plus 100,000 GSU is less than or equal to 282,000. So mao na ning sa tanan. So dapat atong magasto is dili mo labaw sa gi-estimate na nato nga budget. And lastly, the non-negativity. DFR, DSA, DSU, EFR, ESA, ESU, GSU is greater than or equal to 0. So, the management scientist solution is diri nagka-come up tas objective function of 199,000. Na-come up na to value sa each variable. So, the summary of our solution, the total new audience reach is 199,000. And ang value sa number of daytime ads on Friday is 8. Sa daytime ads on Saturday is 5. Sa daytime ads on Sunday is 2. Sa evening ads on Friday is 0 as well as sa Saturday. And sa evening ads on Sunday is 1. And sa number of daytime ads on Sunday is 2. So we will now tackle marketing research. So marketing research was conducted by a firm to learn about consumer characteristics, attitudes, and preferences. So each services includes designing the study, conducting surveys, analyzing data collected, and providing recommendations for the client. So in the research design phase, targets or quotas may be established for the number and types of respondents to be surveyed. The marketing research firm's objective is to conduct the survey so as to meet the client's needs at a minimum cost. So we have here an example of marketing research. Market Survey Incorporated or MSI specializes in evaluating consumer reaction to new products, services, and advertising campaigns. A client firm requested MSI's assistance in ascertaining consumer reaction to a recently marketed household product. During meetings with the client, MSI agreed to conduct door-to-door personal interviews to obtain responses from households with children and households without children. In addition, MSI agreed to conduct both day and evening interviews. So, they agreed to conduct door-to-door interviews from households with children and without children to both day and evening. So the client's contract called for MSI to conduct 1,000 interviews under the following quota guidelines. So one of the variables that they want to gather data about households with children and households without children. And the other one is doing interviews during the day and evening because as we all know, people work and sometimes dili sila available during the day and so on. So first, we have here interview at least 400 households with children. Second, interview at least 400 households without children. Third, the total number of households interviewed during the evening must be at least as great as the number of households interviewed during the day. So, they have to interview just as many households in the evening as they are done in the day. And then fourth, at least 40% of the interviews for households with children must be conducted during the evening. And lastly, at least 60% of the interviews for households without children must be conducted during the evening. Next is we have here the interview cost. So the cost in daytime in households with children is $20, while in the evening time is $25. And in the daytime for the households without children costs $18 and $20 in evening. So as what we can see, the cost varies with the type of interview. So compare sa cost of daytime, mas labaw pa ang cost sa interviewer sa evening time And compare sad sa cost sa interviewer sa households without children, mas labaw sad ang cost sa households with children. So based upon this, we have to formulate a linear programming problem and solve it to figure out how many interviews are we conducting for this particular client. So in formulating the linear programming model for the MSI problem, we utilize the following decision variable notation. So first, let's begin with the decision variables. So as usual, step 1 is always decision variables. So what are the decision variables? So actually, we have 4 variables. So we have here DC, EC, DNC, and ENC. So DC as the number of daytime interviews of households with children, EC as the number of evening interviews of household with children, DNC as the number of daytime interviews of household without children, and ENC as the number of evening interviews of households without children. And of course, the objective is to minimize total cost. So the objective function is 20 DC plus 25 EC plus 18 DNC plus 20 ENC. The constraint requiring a total of 1,000 interviews is DC plus EC plus DNC plus ENC is equals to 1,000. The next constraint is you have to do at least 400 interviews of households with children and 400 interviews of households without children. So for households with children, we have DC plus EC is greater than or equal to 400. And for households without children, is DNC plus ENC is greater than or equal to 400. Other than that, we have also other constraints. So the next constraint is the total number of households interviewed during the evening must be at least as great as the number of households interviewed during the day. So they have to interview equal or more people in the evening. So it says the total number of interviews in the evening has to be greater than or equal to number of interviews during the day. So that should be EC plus ENC is greater than or equal to DC plus DNC, or if we move all of these variables to the left, it will become negative DC plus EC minus DNC plus ENC is greater than or equal to 0. Next constraint is at least 40% of the interviews for households with children must be conducted during the evening. So, 40% of households with children must be done in the evening. So, it should be at least 40% of the total number of the interviews. So, which will be EC is greater than or equal to 0.4 times DC plus EC, or negative 0.4 DC plus 0.6 EC is greater than or equal to 0 if we move all of these variables to the left. So, the DC plus EC is the total number of interviews for households with children both during daytime and evening. So, at least 40% of it must be done in the evening. So, at least 40%, so it could be more than that. So, it could be 50%, 60%, and so on. That's why we are saying it is greater than or equal to 0.4 or 40%. Then, let's proceed to at least 60% of the interviews for households without children must be conducted during the evening. So, similarly, at least 60% of households without children must be done in the evening. So, it should be at least 60% of the total number of the interviews, which will be ENC is greater than or equal to 0.6 times DNC plus ENC, or negative 0.6 DNC plus 0.4 ENC is greater than or equal to 0 if we move all of these variables to the left. So the DNC plus ENC is the total number of interviews for households without children both during daytime and evening. So at least 60% of it must be done in the evening. And let's not forget the non-negativity requirements, which is DC, EC, DNC, and ENC is greater than or equal to 0. So these are the objective function and the 6 constraints, and when we put these constraints in the Excel and solve them, we can come up to the answer of the minimum total cost of $20,320. So as what we can see, the objective function is 20,320. So the number of interviews of households with children in daytime is 240 and the evening time is 160 with a total of 400. And the number of interviews of households without children in daytime is 240 and in evening time is 360 with a total of 600. And the total will be 480 in the daytime, 520 in the evening time, and 1,000 in overall. So those are one of the examples of media selection problem and media research problem that a marketers or managers might encounter. So next topic will be financial applications to be reported by Mr. Padernal.
Hello everyone, I am Calgary C. Padernal, second reporter of Group 4 in Chapter 4, Linear Programming for Financial Applications. So, in financial applications, linear programming can be used in financial decision making that involves capital budgeting, make or buy, asset allocation, portfolio selection, financial planning, and more. So in portfolio selection, problems involve choosing specific investments, for example, stocks and bonds, from a variety of investment alternatives. So this type of problem is faced by managers, banks, mutual funds, and insurance companies. So, ang kining financial applications is usually, iyang objective function is maximization of expected return or minimization of risk. So next, we have an example here of portfolio selection. When we say portfolio selection is, we choose a solution from different alternatives. So here, we have Winslow Savings has 20 million available for investment. It wishes to invest over the next 4 months in such a way that it will maximize the total interest earned over the 4-month period, as well as have at least 10 million available at the start of the 5th month for a high-rise building venture in which it will be participating. For the time being, Winslow wishes to invest only in 2-month government bonds, earning 2% over the 2-month period, and 3-month construction loans, earning 6% over the 3-month period. Each of these is available each month for investment. Funds not invested in these two investments are liquid and earn 3/4 of 1% per month when invested locally. So, we need to formulate a linear program that will help Winslow Savings determine how to invest over the next 4 months if at no time does it wish to have more than 8 million in either government bonds or construction loans. So let's analyze again the problem. So here, we have Winslow Savings has 20 million available for investment. It wishes to invest over the next 4 months in such a way that it will maximize. So maximize man siya. So this will be the maximization problem. Total interest earned over the 4-month period. Invest to the next 4 months man. So next 4 months. So let's label it. As well as have at least 10 million available at the start of the 5th month for a high-rise building venture in which it will be participating. So at the start of the 5th month, no, kay may invest na pod sila sa high-rise building. So next is, for the time being, Winslow wishes to invest only in 2-month government bonds. Here, 2-month government bonds earning 2% over the 2-month period. Mo earn siya og 2% ighuman sa 2 ka buwan. And 3-month construction loans earning 6% over that 3-month period. So mo earn siya 6% after 3 months. Each of these is available each month for investment. funds not invested in these two investments are liquid and earn 3/4 of 1% per month if when invested locally. So we have tulo na ka alternatives here, constraints. So we have government bonds, we have construction loans, we have construction loans, construction loans, and we have local investment, so L. So here, after 2 months, kaya na siya tubo na 2% at the end of 2 months. Sa construction loan sad, kaya na siya tubo na 6% after 3-month period. While local investment, na siya tubo na 3/4 of 1%. So, ato ni isolve. So, 3/4 of 1% is 0.75%. So, next. So, formulate a linear program that will help Winslow Savings determine how to invest over the next 4 months. If at no time does it wish to have more than 8 million in either government bonds or construction loans. So, if at no time does it wish to have more than 8 million in either government bonds or construction loans. So, it should be less than 8 million. So less than or equal to 8 million. So next is we need to define our decision variables, no? So here we have G. So G sub I stands for amount of new investment in government bonds in month I. So let's also add here variables letter I, which is at the beginning of each month. Beginning of each month. So we have C sub I, amount of new investment in construction loans in month I. So this is for construction loans. While L sub I is the amount invested locally in month I. So this is the local investment. Next is we need to define the objective function, no? To maximize the total interest earned during the 4-month period, which is stated by the problem. So we need to maximize interest rate on investment times amount invested. So this is the maximization. So 0.2 giga ni siya sa 0.2% na interest rate sa government bonds after 2 months. Then this is month 1, month 2, month 3, and month 4. So here we have also construction loans which na naay a multiply of 0.6, which is 6% interest rate over on the 3-month period. So this is construction loans, 6%. And so added ang month 1, month 2, month 3, and month 4. And we have also 0.0075 times month 1 of loan local investment. So nakuha ni nato siya is from the 3/4 of 1%. So every month motubo siya og 0.75% for local investment. So kay na define naman nato ang objective function which is maximization. So we need also to define the constraints. So here we have month 1's total investment limited to 20 million. Why 20 million? Because it is stated in the problem, stated na sa situation ni ay. So we have the first constraint. So G sub 1 or month 1, C1, L1 is equal to 20 million. 20 million is limited to 20 million man, so 20 million will be divided for this for government bonds, pila invest construction loans, pila invest local investment. In month 2, after 2 months, total investment is limited to principal and interest invested locally in month 1. So we have month 2. So G2 for month 2 of government bonds, C2 for month 2 of construction loans, and L2 for local investment is equal to 1.75 L. 1.0075 L1. Ganong name siyang 1.0075 L1. Why not 20 million? Kay since this is month 2 naman, condition sa local investment, mutubo siya og 75% per month. So, mana naman ang month 1. So, this is month 1. Month 1. This is month 2. At the end of the period of month 1, kani earn na siya og 75%. So, ang itabo is ang money siya na itabo na nitubo na siya 0.75% ang month 1 sa local investment. This is for local investment. So, at the beginning of month 2, sa local investment, should be natay tubo 100%, which is kaning 1 plus 75%, 0.75% times the value of month 1 mo na ato ang interest earned for the first month. Interest earned for the first month. Sa local investment lang na. Why not? Anong wala man appeal ang G2, government bonds, ug C2? Kay ang condition aning G2 is after every 2 months kay mo earn siya og 2%, while ang construction loans after every 3 months mo earn siya og after 3 months mo earn siya og 3%. Or you can use this constraint, no? If dili mo ganahan ani na di mo comfortable ani first constraint. So you have 2 choices. Next, we need to define the constraint number 3. So let's see, month 3 is total investment amount limited to principal and interest invested in government bonds in month 1 and locally invested in month 2. So here in constraint number 3, we have government bonds month 3 plus government bonds construction loans month 3 plus local investment month 3 is equal to 1.02 local government bonds plus 1.0075 L2. So why as I've said earlier, ang government bonds is it will take 2 months to mature and grow 2%. So mana ni siya ni tabo. So diri na sa pag-abot na to sa month 3, nakita tay at the end of month 2 kay nitubo naman ang government bonds of 2%. So month 3 start na sa month 3 nanay 1.02 na tubo ang government bonds sa month 1 niya. While ang local investment nitubo na ang ikang kadua month nitubo na sa dog kuan 1.075. Or you can use this constraint if dili mo comfortable sa first. Then in month 4, total investment limited to principal and interest invested in construction loans in month 1, government bonds in month 2, and locally invested in month 3. So we have this constraint. So month 1, government bonds G4 plus C4 plus L4 is equals to 1.06, 1.02 G2, and 1.0075 L3. So this is month 4, no? So after sa 3 months, ang condition man sa construction loans is mutubo siya 3% after the 3-month period. kay nitubo naman siya 6% sa at the end of month 3. So in month 4, ang iyang gi-invest on month 1 will be multiplied to the rate of interest, which is 6%. So mutubo na siya 6%, no, 6%. So construction loans i-multiply na to, so mo na siya sa construction loans. So while on government bonds on month 2, kay di ba ang condition kay after 2 months mo start na siya og return of 2%, so mag-return na siya, so month 2 na sa di multiply na to og 1.02, and kani sabdan na to na every month. So next is, sa problem is states dito na 10 million must be available at the start of month 5. Since this is month 4 naman, so at the beginning of month 5, we need to have 10 million available. So here, so it should be greater than or equal to 10 million. Ang tanang kuan sa month 2 na rate plus government bonds na month 3 na rate plus 4th month sa local investment. Next is we have constraint number 6. So no more than 8 million in government bonds at any time. So the statement sa problem no more than 8 million government bonds at any time. Also, doon ni sila kabuok, government bonds and construction loans. So here, this is government bonds. The next slide will talk about the construction loans. Construction loans. So back to sa government bonds. Government bonds. So in the first month, no more than 8 million. So meaning na less than siya, less than. So we have here less than 8 million. So here, constraint number 7. So we have at the end of month 1, beginning of month 1 plus beginning of month 2 is less than 8 million. Nganong naglahi man ni ang constraint number 6 o constraint number 7? Kay first, kuan pa man ang constraint number 6 is kani pa siya ang first month, wala pa nahitabo ang second month. Wala pa nahitabo. So pag after sa month 1 na natay month 2 no. So in constraint number 7 dire gi-illustrate na ang month 1 ug month 2 na nahitabo na, so it should be less than or equal to 8 million. In constraint number 3, we have government G2 plus G3. So why G2 plus G3? Wala may G1. So the statement dito sa problem na mo earn sa interest 2,000 per month over the next after 2 months. So meaning mana naman ni ang kuan G1 hitabo naman ni. So ang the next 2 months will be G2 ug G3. So mo ni ang gimbuot pasabot sa constraint number 8. So kanila sa nang atong 2 months ni sila for 2 months. So ang rate nila, rate sa 2 ug plus sa rate sa 3 is should be less than or equal to 8 million. Sa constraint number 9 naman sad, same gyapon pero wala na ang 2 G2. So we focus sa G3 ug G4 kay 2 month period. 2 month period man, excuse me. So it should be less than or equal to 8 million. So next is dire na sad sa construction loans. So same gyapon, month 1 wala pa nahitabo ang month 3 to 4. So it should be no more than 8 million, so less than or equal to 8 million. Next is constraint number 11, C1 plus C2 is less than or equal to 8 million. Then constraint number 12 is C1 plus C2 plus C3 is less than or equal to 8 million. So ganun tulo naman ka variables dili pareha sa government bonds na duha ra pag ika-third na constraint. So ang explanation ana is ang sabot man dire is amo earn siya og 6% interest per month after 3-month period. 3-month period. After 3-month period no. So we have first month second month, third month. This is the 3-month period. So after anak mo earn na siya 0.06 na interest, and it should be less than or equal to 8. Same explanation sad sa constraint number 13, which is gitangtang na to ang constraint number 1 kay mana naman siya. We have constraint number 2 plus constraint number 3. Construction loans 2, 3, and 4. So, less than or equal to 8 million. So, in non-negativity, so dili man pwede na ang atong may equal sila og 0 ang return. So, dapat it should be greater, no, not less than, not equal, less than. Dapat, dili sila dapat mo less than sa 0. So, we have the government bonds, construction loans, local investment to be greater than or equal to 0. For months 1, 2, 3, 4. So here we have this computer solution. So how do I come up with this objective function value? So ang gigamit ani sa book is through Excel solver. We have Excel solver. You need to use Excel for it to solve these values. So we have these government bonds, construction loans, and local investment. So mo ni ang ma-return nila sa kuan dito sa if gamit kag Excel solver. Okay, gets? Okay, let's proceed to next. We have a financial planning problem. We have financial planning problem. So let's read first. So Hewlett Corporation established an early retirement program as part of its corporate restructuring. At the close of the voluntary sign-up period, 68 employees had elected early retirement. As a result of these early retirements, the company incurs the following obligations over the next 8 years. So we have year 1, year 2, year 3, year 4, year 5 to 8. At the end of the period, we have 430. Dapat nakatigom na sila og 430,000, makatigom og 210,000, 231, and so on. The cash disbursement requirements, the cash requirements in thousands of dollars are due at the beginning of each year, thousands of dollars. So dili sila 430 dollars it's 430,000 dollars as stated in thousands of dollars. Next is the corporate treasurer must determine how much money must be set aside today to meet the 8 yearly financial obligations as they come due. The financing plan for the retirement program includes investments in government bonds as well as savings. The investments in government bonds are limited to 3 choices. So we have here bond 1, bond 2, bond 3. Money ilang price and years to annual rate. Mature siya at the year 5, mature ang bond to year 6, yung mature siya year 7. So next is the government bonds have a par value of 1,000, which means that even with different prices, each bond pays 1,000 at maturity. The rates shown are based on the par value. For purposes of planning, the treasurer assumed that any funds not invested in bonds will be placed in savings and earn interest at an annual rate of 4%. So again, let's analyze the problem. Pen. So here, this is 1,000 na, K na sila tanan because it's stated in thousands of dollars. Here, money, we have bond 1 which is money lang price, rate, and maturity. And here, the government bonds have a par value of $1,000. Even na sila ay different prices. Pareha to sa last slide which is here, kani price. Nganong dili 1,000, nganong 1,500 man siya. Because it is stated also in the problem that Even with different prices, each bond pays 1,000 at maturity. So, atong sabton, after sa year 5, at the beginning of year 6, maplasan siya og $1,000. Kini mature naman sad siya. The same as maturity of bond 2, which is on the beginning of year 7, maturity of bond 3, which is at the beginning year of month 8. So, plasan nila to sila og 1K each. Ig mature. So, the rates shown are based on the par value. For purposes of planning, the treasurer assumed that any funds not invested in bonds will be placed in savings and earn interest at an annual rate of 4% for savings ni siya annually per year. No. Eraser. Savings. So here, we need to define the decision variables, no? So, F. So, total dollars required to meet the retirement plan's 8-year obligation. So, we need, this is for funding, no? Funding. So, yes, we have B1. Units of bond purchase. Bond 1, this is bond 1. Purchase at the beginning of year 1. B2, units of bond 2 purchase the beginning of year 1, and bond 3, units of bond 3 purchase at the beginning of year 1. B2, B3. Ako lang tawag ng bond 1, bond 2, bond 3 para di malibog. So, S, this is savings. Amount placed in savings at the beginning of year. So, ganina no sa portfolio selection is, ang I na to is for month, direct kay beginning of the year. So, we have year 1 to 8. Ganong 1 to 8 man na ang man dire is mo 7 years mo mature because ang bond 3 mo mature siya at the beginning of year 8. So, there will be 8 years. So, next is we need to define the objective function. The objective function is to minimize the total dollars needed to meet the retirement plan's 8-year obligation. So, we have the minimization of funds. So, this is our objective function. Next is we need to define the constraints. So, the feature type of this financial planning problem is that a constraint must be formulated for each year of the planning horizon. What do you mean by planning horizon? So, makita lagi na nato ikaw niya ha. So, this will be the formula pag-construct na to sa itong constraints. So, we have funds available at the beginning of the year minus funds invested in bonds and placed in savings. Ganyan sila. Bonds and savings is equal to cash obligation of the current year. Here. So before tamo kuan, this is the planning horizon. When planning horizon, meaning this is the planning horizon for the span of the year 1. This is the planning horizon for year 2, year 3, and so on. So now, reserve. So balik ta. So this will be using this formula, no? Nakita na to sa next page. So cash obligation for the current year. So explainin nako, cash obligation of the for the current year is makuha na nato siya dire. This is the cash obligation at the end of each year. So in the year 1 dapat iguman gyud sa year 1 kinakay 430,000. Dapat sa year 2 na kay 210,000 and so on until maka-reach ka sa 8, which is 255,000 at the beginning of year 8. So here, balik ka sa constraint, no? in order to para madali, first year 1 is wala pa man tay kuan interest rate. So ang gi-base ani kay ang formula. So the formula is this: funds available at the beginning of the year, which is F, minus funds invested in bonds and placed in savings equals to cash obligation of the end of the year. So this is the bonds, funds. Minusa na to sa funds invested in bonds and savings. So we have minus 1.15 minus 1 minus 1.35 minus savings. So asa ni nato nakuha na value kani 1.15. 1.15 is nakuha nato ang value dere. So here this is the price. Kay since ang gitoyo na siya 1.15 is gi-move ditoyo og 3 decimal places. Ngano gi-move man siya og 3 decimal places kay kabantay mo sa year 430. Dili man siya pwede na pesos kay gi-state man siya na thousands. So if thousands siya, so na siya 3 dire. Tulo ka 3. So meaning kay gi 430 man siya gi-move og 3 decimal places. Same tanan. So that's why gi-move sa og 3 decimal places kaning price. So name siya 1.15, 1 og 1.35. So now, we have 1.15, sabot na 1K man ni siya dapat, so gi-move 3 decimal places niya sa bond 3, 1,350 nga gi-move og 3 decimal places minus savings on the beginning of year 1. Since wala pa man tay savings, so this is unknown. So it will equal to cash obligations at the end of each year. So we have 430,000K. 430K. So for discussion purposes, for the conversion processes, dili na tubot nga og K, kay gi-move naman siya og 3 decimal places. Now, for the constraint of year 2, since the beginning of year 2, na siya increase na rate na 0.8875. So kani siya kagika ni siya sa rate sa bonds. Here, i-move gyapon siya 3 decimal places. So same ni sila. No, dili siya gi-move day. Not dili siya i-move og decimal place, but rather gi-convert siya og decimal. This is because this is percent man. So if i-convert ito og decimal, so this will be 0.08875, 0.055, 0.055 and 0.11750. So here, this convert na siya og decimal minus 1.04 on the savings. So nganong nahimo man siya 1.04, nganong dili man siya 0.04? Kay di ba stated man gyud dito sa problem no na ang savings has an annual rate of 4%. Pero ang gilok so nganong naman siya 1? Because this is 100% plus 4% is equals to 104%. But atong i-convert o decimal so 1.04 mo na siyang i-multiply siya sa savings kay mo man siya na increase minus savings of year 2. Since this is the beginning month of year 2 year, so wala pa savings, so it will equals to 210. Next is year 3. Walang gyapon ang pamaagi until year 8. Pero kabantay mo na diri sa year 5 o year 6 ihunong ang bond 1. This is bond 1, bond 2, bond 3. So observe na gi-state sad sa problem na ang bond 1 is mature siya for 5 after 5 years. So, at the beginning of year 6, at underline na, at the beginning of year 6, na siya, ma-addan siya, ang condition also na, if mo mature, ang bond, ma-addan siya og 1K. Muna yung condition sa problem. 1K. So, ang rate na iyang nakuhaan ka nang na-earn at after the end of the year will be reflected on the beginning of the year 6. So, plus 1K, so muna siya 1.08875. Same Japan explanation for year 7 and year 8. So, here came ang bond to mo mature siya after 6 years. Okay, since 6 years mo yung maturity, after 6 years, at the beginning of year 7, maada na sad siya og 1K. Same as bond 3, which matures 7 years. So, after 7 years, at the beginning of year 8, plus na po nato siya 1K, kay ni-reflect naman ang iyang kuan kanang increase sa year 7, so mature na siya. Same as savings minus year 8 savings. Okay, next. So this will be if kani siya dapat i-input ni nato siya sa Excel, no. So ang iyang mahimong naong is kani may siyang nani, pero pwede ra sa ninyo nakuan kanang otherwise kanang pwede ra niya ibago ang style basta makasabot lang gid mo sa kuan problem gid ug sa constraints. So this is an example. So here is below is the link for problem na related ani, pero lahi ang gipangita ato na problem. Pareha gyapon sa Hewlett Corporation, pero lahi ang iyang pamaagi sa solve. Kay iya mang gi mano-mano og pag-solve. Pero ang Excel na siya feature na kanang Excel solver na dali ra maka-solve ato. So this is the solution for the Hewlett Corporation cash requirements problem. So kani sila pag humana tog input sa Excel solver, no, I will Excel. This is an add-in feature ni siya sa Excel solver. Na uban Excel na wala sa Excel solver, pero pwede ninyo i-add sa inyo ang Excel solver sa inyong Excel para maka-compute mo saan sila ani. So first is kitong constraints is you need to input it on the Excel. So mahimong ginaani. So this is bond 1, bond 2, bond 3. So this is the answer na. So funds, ang value sa tong funds is 1728.79385. So this is the optimal objective value. Pero i-answer gani nato dapat dili na to makalimtan na kay since nga gi-move ba na to og 3 decimal places kani sila, 3 decimal places. So dapat i-move sa nato og back to 3 decimal places. So here, don't forget, so we have also the bond 1 value, which is 144, bond 2, 187, bond 3, 228, and S1, which is 636. Gi-calculate na siya tanan sa Excel solver. So, the optimal solution to the 12 variable 8 constraint linear programming problem is minimum total obligation of 1,728,794. So, familiar no? Kani siya nakuha ni nato dire sa F. Kani. Muna siya. So, muna ang gingon na dapat i-move na to 3 decimal places to the original place if imong gi-move ang 3 decimal places. So, here, 794. So, don't forget to round off. So next is here, units purchase. So kani bonds mo ni pila ka book bonds yung napalit. So we have here bond 1 is equal to 144, bond 2 187, and bond 3 228. Gikuha gyapon siya sa Excel solver, no. So we have multiply sa price sa band 1, which is this. So equals to 166,736 plus $1,000. Oh no, $1,000 times this. So it will equal to 187,856, then same sa band 3. So inana siya pag-solve sa financial planning sa linear programming model. So I hope na mo'y nakatunan sa financial applications, and thank you for listening.